to do. I love implicit differentiation. So the objective is students will be able to calculate derivatives of implicitly defined functions. So I want to take a brief moment and look at explicit functions versus implicit. Up to this point, you have learned how to differentiate functions that are expressed in what's called an explicit form. That means it is solved for y or can be solved for y. We will now take a look at relations written in what's called implicit form. So look at this short table. In green on the left, this is y equals x squared plus 1. Now f of x is another name for y, equals the square root of 4x cubed minus 2x plus 1. So we know how to find those derivatives. On the right, it is actually impossible to get y alone. So those are called implicit form. So what I'm going to show you today is how you find the derivatives. On the left, these are in explicit form. So this one's just 3x squared. And over here, this is 1 plus the derivative of y with respect to x. And before I do the ones on the right side, I want to mention something. This really is the chain rule. Up here, we were then doing the derivative of x with respect to x, but what's dx over dx? It's 1. So what you're going to find is then that's why we didn't write it. You didn't know this yet, but we were really doing the chain rule the whole time. So then let's look at letter B. This would be bring down the power, decrease the power by 1, but the inside is y. Okay, the inside is y. I don't know what it is, and so I would have to do dy dx. Then let's look at letter D. I have a product, x times y squared. So I take the first times the derivative of the second. So this is 2y. I don't know what y is, so when I finally get there, I have to do dy dx plus y squared times, and really, technically, and I'm not going to write it, but the derivative of x is dx dx, which is 1. So if I tidy this up, this is 2xy dy dx plus y squared. So with implicit equations, you have the chain rule. We don't bother with dx dx because it's 1 and we know that. But every time you have a y, that's a placeholder for something. So, and we're taking the derivative with respect to x. So I need the dy dx. So here are the guidelines for implicit differentiation. You're going to differentiate both sides of the equation with respect to x. Collect all the terms with dy dx on the left side and move all the other terms to the right side. Then you can factor out the dy dx, and then you'll solve. So let me show you what this means. In example 2, I'm going to go through and differentiate. So this will be 3y squared dy dx plus 2y dy dx minus 5 dy dx minus 2x. If it helps, do dx dx, but then in the next line, that's going to cancel. On the right side, what is the derivative of a constant? I heard it. 0, right? Now, I liked, because this tends to be a little bit tedious. I mean, I personally enjoy it, but some students don't quite enjoy it the way I do, is there's a lot you have to write with implicit differentiation. And so if I can condense things, multitask, I'm going to try. So I'm going to do 2 things in this step. I'm going to factor dy dx out of all the terms that have a dy dx. And at the same time, I'm going to add the term that didn't have a dy dx to the other side. So I did 2 things. I factored out dy dx out of all the terms with dy dx, and I moved the 2x to the other side. And then all I have to do is divide both sides by 3y squared plus 2y minus 5, and there I get my dy dx alone. I don't know. I find this to be super fun. I like to do these. I'm going to do one more where I'm really leading you through it because there's a tricky component to this one. Then example 4, I'm going to give you like 3 or 4 minutes to try this one on your own, and we'll work it together. All right, so let's look at example 3. It says find dy dx for x cubed plus y cubed minus 9xy equals 0. Before we start this one, can anybody anticipate what's going to be a tricky thing? Yeah, Ankit? Okay, that's one issue. You've got to use the product rule, but I guess that wasn't what I was thinking. What's the tricky part in that power rule? What's in front of the product? A negative sign, right? So you're going to have to distribute this minus. So watch what we're going to do here. This is going to be 3x squared. Technically, it's dx dx, but that's 1. Plus 3y squared dy dx, because I'm finding the derivative with respect to x. Minus, now I'm going to put a big grouping symbol. You could do a parenthesis or a bracket. Because when I'm done, I have to distribute the minus sign. It's a little bit too much for me to try to mentally do it. If you can handle it, go for it. So I'm going to take the first times the derivative of the second plus the second times the derivative of the first. The derivative of 0 is 0. So the first times the derivative of the second plus the second times the derivative of the first. So dx dx is 1. So let's tidy this up. So I'm going to subtract 9x dy dx minus 9y. I'm going to multitask. I'm going to factor out the dy dx out of the 2 terms that have it, and I'm going to add the 9y and subtract the 3x squared. Let me repeat that because I did 2 things here. I factored the dy dx out of these 2 terms, and that left me with 3y squared minus 9x. So I'm factoring it out, and then I added the 9y and subtracted the 3x squared. Then I'm getting dy dx equals 9y minus 3x squared over 3y squared minus 9x. On a free response, they love implicit differentiation on free response, okay? They do like that one. They would be absolutely fine to stop here, but suppose this were multiple choice and you don't see this answer. It should be jumping out at you that there's a common factor of 3 in the numerator and the denominator. So if this were a multiple choice, you can cancel common factors. You may not cancel terms. Let me repeat that. You can cancel common factors. So 3 is a factor in the numerator and denominator. So I can cancel like that. All right, questions before we try example 4. Yeah, Quinn? If I had a 3x in the top and bottom, then sure, I could cancel a 3x and 3x to reduce, yeah. All right, let me give you 3 or 4 minutes, and I want you to try example 4. find dy dx. Now watch, we're going to go right back through this again and again. I want you to then in part B find the slope of the tangent line. Now you need x and y. And then write the equation of the tangent line at that point. If you're a fast worker, try the 2 extra practice. But I'm going to try to be patient and let you try these. Tomorrow we're going to play Castle Attack with implicit differentiation. So we're going to play it. I've really been getting into my games lately. So I'm excited. It's a twist. It's not Storm the Castle. We play it a little differently.
Yeah. Radicals be a denominator.
Correct. Yeah, great question. The question was, if you have radicals in a denominator on a free response, you do not have to simplify those. The only difficulty is if the problem is multiple choice, sometimes they'll make you. On this one, I did not simplify any radicals. Again, if you're a fast worker, try the 2 extra practice, but I'm trying to be patient, let everybody get through this one before I could work it out. But then remember, it's 1 over the stuff times the derivative of the stuff. Yeah, and that's where it's going to get real interesting. All right, I'm going to go ahead and start this one. So I'm going to get 2x plus 8y dy dx equals 0. So I get 8y dy dx equals negative 2x. Then dy dx equals negative 2x over 8y. I think it might be a little bit easier to deal with if I do, in fact, reduce that to negative x over 4y. Then part B says find the slope. Well, the slope is dy dx at the point. So you're going to put negative square root 2 over 4 times negative 1 over square root 2. Yeah?
Isn't this supposed to equal to 4
is what's supposed to equal.
For A, so consider the equation x squared plus 4y squared equals 4, not 0.
The derivative. Yeah. I'm so glad you asked that. That is one of the most common mistakes. Is it bothers us with that 4. So you're actually taking the derivative of both sides. So the derivative of a constant is 0. So that does not equal 4. That's a really good question. All right, so I'm getting negative square root 2 over negative 4 over square root 2. Oh, what happened to my screen? Thank you. There we go. 2 negatives become positive, and when you divide by a fraction, that's the same as multiplying by the reciprocal. So my slope is 1/2. Now, of course, you could stop here, but that's going to make it a super ugly equation. And so then this is going to be y plus 1 over square root 2 equals 1/2 times x minus square root 2. All right, so there were some fractions to deal with there. And again, I don't think we're having really much trouble with calculus. We're having trouble with some algebra. But we're trying to build the foundation, okay? So now that I'm going over a complex fraction, multiply by the reciprocal. Let's see if we can't put that now in our math tool belts to be able to draw from. All right, questions? Anything else on example 4? All right, in the extra practice, number 1 is a multiple choice problem. It says if y equals the natural log of x squared plus y squared, then the value of dy dx at the point 1, 0 is. So let me show you kind of an easier way to do this one. If you know the point, you don't need to do any simplifying. So let me show you what I mean by that. This would be dy dx. Okay, the derivative of y is dy dx. Do you remember that if I have y equals the natural log of u, what's the derivative? Good job. 1 over u times, we can call it du, or just the derivative of u. So I'm going to take 1 over my stuff times the derivative of the stuff, which is 2x plus 2y dy dx. Now, I would be a little bit afraid if I had to just find dy dx, because I don't even know how I would do that. The good news is I don't have to, because it says find dy dx at 1, 0. So watch what happens. I'll change colors so you can see what I'm doing here. This is 1 over 1 squared plus 0 squared. 2 times 1 plus 2 times 0 times dy dx. Oh, thank goodness. So this is 1 over 1 times 2. That's letter choice D. Let me kind of go over this again. I'm taking my derivative, and I know x is 1, y is 0. So it's 1 over 1 squared plus 0 squared, so that whole thing is 1. So that's good. I can just ignore it then. This is 2 times x. 2 times 1 is 2. Thank goodness, y is 0. Anything times 0 is 0. So that whole thing is 0. So that's why that's 2. Any remaining questions on that multiple choice? All right, then number 2. I'm going to pause a moment, and it says calculate, and that stands for y double prime. That just means the derivative of the derivative. And we saw that yesterday when we did our scavenger hunt, the d2y over dx2, that just stands for the second derivative. So I'm going to pause a moment. And if you haven't started it, at least get to your first derivative. If you've worked on it, see if you can keep going. The good news is section 3.6 is doing the second and third derivatives. So, like, we're going to spend half of a period on that because we've been doing it. To me, that's not anything new. So today we're done with all the new content for our quiz on Monday, but implicit differentiation takes a little bit of practice to get the hang of it. So I am going to spend tomorrow just letting us practice. Friday will be a review, and Monday will be the quiz. Then next week, we're going to rapid fire do 3-3, 3-4, 3-5, 3-6 review, and then have a one-day test so you kind of know where we're headed. 3-3 and 3-4 are a little bit harder, but then my 3-5 is just, hey, if you're given any situation, how do you find the derivative? So 3-5 is nothing new, and 3-6 is nothing new. So I'm sort of using those as my buffer days to help us with 3-3 and 3-4. Yeah. Sure. All right, I'm going to go ahead and start it. 2x plus 8y dy dx equals 0. So if you're going to go to a second derivative, it's helpful to simplify your first derivative, okay? All right, how many of you, can you give me thumbs up? How many of you got the first derivative? Oh, yes. Okay, so now watch this. I have a quotient. So what are we going to use to find the second derivative? The quotient rule. Low d high minus high d low over low low. Whoops, okay, hold on. So the way that we write that is d2y dx2. So here we go. Low d high minus high d low. Now be really careful. That's 4 dy dx all over low low. Now, when you're asked to find the second derivative, you're not allowed to leave dy dx in your answer. We know what dy dx is. We found it right above. So watch what's going to happen. This is going to be negative 4y. It becomes plus 4x times negative x over 4y over 16y squared. It is absolutely fine on a free response to stop there. Okay, if you were just asked to find the second derivative, it is okay to stop there. But what if this is multiple choice and I don't see this as an answer choice? So I'm going to go ahead and simplify this just for the sake of preparing you for a multiple choice question. So this would be what? Minus x squared over y over 16y squared. Then I'm going to build a common denominator up in the top. So you're going to find that complex fractions come up a lot. So that's giving me negative 4y squared minus x squared over y over 16y squared. So that's negative 4y squared minus x squared over 16y cubed. Yeah.
When you got your final answer, what happened to the 4 when you kept going?
Up here,
Yeah, after the start, you had the 4.
do you see the 4s canceled?
Oh, okay.
Yeah, great question. Great question.